Attention all stations. The 10:45 p.m. current New York time coverage of the Apollo 10 mission is being extended to 11:30 current New York time. The 10:45 p.m. to 11 p.m. coverage will be sustaining. There will be station breaks of 62 seconds at 10:58, 56, and at the end. We will resume at 11 o'clock straight up with a clean opening. Those stations desiring to do their local news from 10:45 to 11 may do so, except stations on the Pacific Network. The 11 to 11:30 portion will be sponsored by Western Electric. Thank you.
This is a CBS News special, The Flight of Apollo 10. Reporting from the CBS News Apollo headquarters in New York, correspondent Walter Cronkite.
Good evening again, and the flight of Apollo 10 continues to go well. At this moment, they are just 5 miles apart. The lunar module with Tom Stafford and Eugene Cernan aboard, and the command module with John Young at the controls. They've been apart for almost 8 hours now since they separated earlier today in a dramatic moment behind the surface of the moon, behind the other side of the moon, out of touch with Earth. And then when they came around, we learned that they had successfully undocked. And through the afternoon, we listened as the lunar module swerved down to within 10 miles of the moon's surface. On the second trip around, went through a dramatic moment. We had 8 heart-stopping minutes there earlier this evening as they went into wild gyrations in that lunar module after separating from their descent stage. We've found out what the problem is, and we'll be looking at that in a moment. What has happened since that time, they fired their thrusters of the lunar module ascent stage at that low point over the moon and began the rendezvous maneuvers. At 9:32 this evening, they were 86 statute miles behind the command module and 17 miles below it. Since they were below the command module, they were going faster than the command module around the moon. They were catching up, so at 10:09 this evening, they began braking, as they were some 30 nautical miles behind at that time. At 10:45, as we came on the air just a minute and a half ago, they were in their 15th revolution around the moon, the lunar module 5 miles then from the command module. By 10:54, which is just a few minutes from now, they will match their velocities at 100 feet apart. And at that point, they will consider that rendezvous has been achieved. The lunar module will be slightly ahead of the command module at that point. They will hold their stations 100 feet apart, and at 11:19 this evening, that's Eastern Daylight Time, and it's now 10:47 Eastern Daylight Time, they will dock. 25 minutes after that velocity matching maneuver. Stafford and Cernan then will spend about an hour cleaning up the lunar module, although goodness knows why, since they'll be sending it off into space shortly after that, never to be seen again. But they will be taking readings from all of the instruments and that sort of thing, stowing gear, and then climbing back at 12:19, shortly after midnight, into the command module. And the separate maneuvers of Snoopy will have been completed. At 1:09 a.m., they will jettison poor old Snoopy, say goodbye to them once and for all, and just 30 minutes after that, they will fire Snoopy's engines by remote control, sending him out into a solar orbit, where he will stay, presumably, forever. Then tomorrow at 7:20 a.m. we get or 7:20 p.m. in the evening, we get television again after a day of tracking of the moon. We get one more look at the moon before on Saturday morning at 6:20 a.m. they fire to return to Earth for a splashdown on Monday. We can listen now to what the ground told the astronauts about how they figured out that problem they had during those dramatic 8 minutes earlier today.
Snoop, Houston, over.
Go ahead, Houston.
Roger, we think we can help you psych out your problem there at staging. It looked like the mode control switch was in auto instead of at hole, over.
Okay, we'll try to recollect it. I probably went right through a checklist as prescribed, but you got the limit, that'll sure help us.
Snoop, Houston, we noticed on your checklist at minus 14 minutes prior to insertion that we have an omission on the mode control switch. It doesn't call out its position there, and we think that's where we ran astray. Over. Snoop, Houston, over.
Go ahead, Houston.
Roger, Tom. Would you like some further amplification on the staging problem? We think the error came at minus 14 minutes where we failed to call out the AGS mode control switch in at hole. Over.
Okay.
We'll try to give you an explanation of what happened during the staging sequence. The backup guidance system, the AGS or abort guidance system mode control switch was in auto because the radar had been used to track the command module, and they were using the auto mode for reaction control system attitude control. Now, this mode control switch should have been placed in attitude hold for staging, but it was not because that step had been omitted from the checklist. So the control system maneuvered the lunar module to lock onto the command module as the computer directed, but that was not the proper attitude for staging. And the crew, we're not sure whether they went to pulse mode or to straight manual control, but they went to one of those two modes and to get out of that situation. And the staging went well.
They were pretty worried about it before Stafford got control of it, though. They were only 13.5 miles above the moon's surface, no position to be wildly gyrating, which was the way they reported it. As Cernan said, the lunar module that they were riding just took off on us as they jettisoned that descent stage. He said, I thought we were wobbling all over the sky. He said, boy, I don't know what the hell that was, baby, but I tell you, there was a moment there. But then they quieted down very shortly thereafter as Stafford got control of the lunar module, and all turned out to be well. You heard in that explanation from Mission Control the reference to AGS. That's AGS for Abort Guidance System. And perhaps if we go out to our correspondent Nelson Benton and the test astronaut for Grumman Aircraft, Scott McLeod at Grumman Aircraft, they can tell us just what that's all about.
Walter, there are a couple of acronyms we have been hearing quite frequently, AGS, as you mentioned, and PINGS, which stands for Primary Navigation and Guidance System. Scott, which is which and which does what? Why do we have an abort guidance system?
Well, one question at a time. This is the PINGS, their primary system. Entry into this computer is by a keyboard, this display and keyboard here. We punch these keys and enter our information into the computer. That over in the corner is the AGS, the abort guidance system. Basically, the PINGS can do everything that we require of it during the mission, and the AGS can't do quite as much. It's, I guess you would say, the backup guidance computer.
Actually, Walter, we're told that abort guidance system, as used in this context, is perhaps not a very good name for this backup guidance system, but it comes out at AGS. If you call it the backup guidance system, it would come out BGS, and people would be calling that bugs, so they call it the AGS.
Thank you, Nelson. Now, with that problem settled, the next big thing is actual docking. Rendezvous is being achieved at just this hour, and now the problem is to bring the two spacecraft back together again, to lock them together so that the two astronauts in the lunar module can crawl back through that tunnel into the safety of the command module for the trip home. For that technique that will be used by the command module pilot, John Young, we can go out to Downey, California, the North American Rockwell's plant there, where correspondent Bill Stout and test astronaut Leo Krupp are standing by. Gentlemen?
Walter, I think Leo can give us a pretty good idea of what they have to go through in this rendezvous. Once they get in sight of each other, I guess technically, Leo, it is rendezvous, even though they may be a good distance apart.
Well, the rendezvous phase will start at 100 feet, and then the lunar module will fly into very close proximity to the command module, up to within maybe 3 or 4 feet, actually, of the command module, before the lunar module will go into attitude hold. The command module will then become the active vehicle for the actual docking. Now, on Apollo 9, Jim McDivitt stayed active in the lunar module all the way in and did an active LEM docking. But as you remember, he had quite a bit of difficulty because our target is very small in the command module, and he had trouble lining it up. But on the lunar module, we have a very nice big target, as you can see here. Now, in looking at this target at the present time, you can see that we're a little bit too far to the left. So the first thing John will do is translate his vehicle to the right until he gets that standoff cross superimposed on the back cross. That'll give him the proper line of sight for the docking. And then the lighted reticle that you see is the COAS, or the crewman's optical alignment sight. Now, this tells him if he has the proper vehicle attitude. Now, actually, our nose is pointed a little bit high and to the right, so he'll take the rotation hand controller and he'll maneuver the vehicle in attitude to bring that COAS reticle down right on the docking target. Now, when the COAS reticle is on the target and the cross is superimposed as it is right now, we have all conditions satisfied for docking. He will then start to move in on the lunar module at about 0.25 feet per second, very slowly, until the probe and drogue mate and he's in a soft dock condition.
Walter, I was talking with Leo a few days ago about that circle of dots. You see the light dots and the black circle around the standoff T? Those are radioactive material, Leo.
That's right. They're a reflective material, Bill, and we have them on there in case it's necessary to do a docking in darkness. Now, we also have a docking light on the command module located outside the command module above our heads, which will shine on this target. And if we had to do a docking in darkness, these dots would illuminate, and we could actually see the target well enough to do a docking on the dark side.
Well, the reason, Walter, for using radioactive material in those dots is visibility, obviously, perhaps in the blackness of the far side of the moon. And yet, the restrictions that our government lays down on radioactive material are so severe that many of the astronauts had a hard time getting close to the radioactive material they might face for the first time in outer space. The rules about using radioactive stuff of that sort on Earth are that stringent. And I guess there were a good many meetings before they finally got around to the point where they actually showed the astronauts the kind of radioactive dots they could expect someday to meet in the blackness of outer space.
Have any idea, Bill, why they had to go to a radioactive material rather than the kind of fluorescent stuff we use here on Earth and bumper stickers and everywhere else?
Leo, it won't work, will it?
Well, I don't know the technical reason why, Walter, but I think the problem was we had a more reliable reflector in this type of material is the reason they went to it. And the simulations we've run on the actual docking targets have been very satisfactory, so it is doing the job.
It's one more of those mysteries of the airless, weightless atmosphere of space. They found that radioactive materials do work, and they're not too sure about those things that people put on your bumper, Walter, and mine.
Thanks a lot, Bill, for the reassurance tonight. Well, they're on the far side of the moon, but if all has gone well, they're now within 100 feet of each other, and they'll be reacquiring a signal here in about 9 minutes for the docking maneuver a little later on. This is Walter Cronkite at the CBS News Space Center.
This has been a CBS News special. The flight of Apollo 10. CBS News coverage of Apollo 10 will resume following station identification. This is CBS.